Alright, so that video just cut off. I'm not sure exactly where it cut off, so I'll try and start off where we were at. So I think it got to here. So we have the exact same equations, just with an inequality. We still have to break into our two cases. So x plus 3. We still have the positive and the negative case. And the hardest part is to remember to flip the sign on the negative case. And when we solve for x, these are our two answers. Notice that they look very similar. They look very similar. The only thing that's different is instead of the equal sign, they're now inequalities. Awesome. Okay, I want you guys to do, I'm going to give you 1, 2, 3 to do on your own. And I want you to actually solve them with the equal sign and with the inequality. Okay, so I'll give you 3 of those now, and you're going to be doing these on your left-hand side. All right. First one. This is number 1. So you're solving the equals and the less than 1. Okay, for number 2. Alright, so do those two on your left-hand side. Remember you're solving the equals and the less than. Their answers should look very similar. Okay, cool. So you're back with me. So what we're going to do is we've learned actually all that we need to about this, how to do this. So we haven't learned how to graph it. So you already know how to graph it. It's just going to be a reminder basically. So let's say I'm going to erase these. Those should be done on your left-hand side already. And we're going to do a couple together. Absolute value of x plus 4 minus 10 less than or equal to negative 2. Alright? Remember, we don't make any assumptions until we solve the whole thing out. So, for this case here, we need the absolute value to be isolated. So you guys should know how to do this. You can work it out on your own and skip through the video if you want. You add 10, right? Absolute value of x plus 4 less than or equal to 8. Okay? You're still going to break into two cases, just like we've done before. X plus 4 is less than or equal to 8. X plus 4, flip the sign, went into negative 8. Okay, when we solve this out, because we want x to be isolated by itself, so you get x is less than or equal to 4, and x is greater than or equal to negative 12. So when we graph this, we're going to be graphing this on a number line, which you guys have done before and seen before, right? I'm going to put my 0 here, my negative 12, and my 4. Okay? Notice I'm only really putting my endpoints because those are really all that matters. Is my 4 is on my graph where it should be. 0 I always use as a reference, and negative 12 is there. And we're going to go ahead and graph these. So these are where we graph with either an open or a closed circle. And when we graph, we're either going to put an arrow to the right or to the left, depending on what this says. So this one right here, if we could use our trick, right, of thinking that the arrow is facing that way, according to this symbol. So our dot is going to be a closed dot on 4. Why closed? Because the line underneath. Okay, and the arrow is going to be pointing to the left. I'm not going to shade all the way yet because I want to see what my other endpoint's doing. So right here, this one, our endpoint's at negative 12 with a closed dot. why I closed out, because of that line. And if we use our trick, the arrow is pointing this way because of the shape of that sign. The arrow is pointing this way. Notice that the arrows are pointing towards each other, so if we were to shade, it would be everything in between. So we don't really need the arrows because it's just everything in between the two endpoints. And this is what we call an AND graph, right? It's an AND in between. Okay? So you need to be able to read these and graph them, because that's what we're going to have to do is solve it, graph it. Good. So if I asked you for some solutions to this right here, some solutions could be 0. 0 is a solution, it's in the shaded, so x equals 0 would work when I plugged it into here. Negative 10, that works. Good. 4's got a closed circle, so 4 works. Okay, these are all solutions. They're all in my shaded area. Remember, shaded means solutions, and they would all work when I plug them in for x. Okay, great. I'm going to give you about 2 of these to do. Right, there's one of them. Here's the second one. So your instructions are to solve and graph. Remember, when you're graphing on a number line. Okay? Alright, so work those 2 problems out on your left-hand side. And then we're going to do one last portion of this. Okay, so you should work this out on your left-hand side. I'm not going to give you those answers. I am going to explain one last thing about this to maybe help, maybe confuse. We'll see, but it is in your book, and it is kind of important to start mentally understanding what we're doing here. So I'm going to do a little bit of work with the graphs. Let me be clear, if you do not fully understand what I'm about to do for the next 5 or so minutes, it's okay, right? It's okay. It's more of like a conceptual understanding of what's been going on in these last 2 lessons. So let me say that again. If you don't completely understand the next 5 minutes of this video, it's okay, right? Perfect. So some things that we're going to look at is we're going to look at graphing. So we're going to be graphing. We're going to be graphing absolute value equations, and we're going to be solving those absolute value equations. Okay? So, let's do absolute value of x minus 3 minus 2 equals negative 1. Okay. So we have learned to identify what the A, H, and K is of a standard form of an absolute value. So what we're going to do right now is we are literally going to completely ignore this negative 1, and we are going to graph this absolute value, which I will remind you should be in the shape of a V, facing upward, because this A is positive. Okay? So, when we identify our A, H, and K, alright, our A is 1, positive 1, our H is positive 3, and our K is negative 2. Which means that our vertex is at 3, negative 2. So we're going to start there. 3, negative 2, that's our vertex. From there, we're going to use our slope of up 1, over 1, up 1, back 1. Alright, and so on to get our V, remembering that our V should be symmetrical on both sides, opening upwards because the A is positive. Okay, now we've graphed it. Great, we got that. So we basically dealt with this whole side of the equation. Now we got to figure out this negative 1 right here. What is that talking about? Well, it's actually in place of the y, right? Typically there's a y there. That's what it took the place of. So what we're going to do is we're going to see, well, here's kind of like a big $1,000,000 question. When does y equal -1? When does that happen, right? That's like the question. Okay? So we'll look and see, let's look at that line. Y equals -1. If we look at that line, y, -1, cross. Okay? So where are the solutions here? Where do they cross? Well, they cross here and here. So let's look at those points. Okay, this is -4, -1. This is -2, -1. Okay? So our solutions are these x values, right? Our solutions would be x is equal to -4 and or x is equal to -2. Those are our solutions, or where it crosses. Okay? Let's kind of check our work to see that you guys actually believe me. So let's say for this right here, if we wanted to solve this, right? If we wanted to solve this, just like we've been doing, we would add 2 to both sides because we want to isolate the absolute value. Absolute value of x minus 3 equals 1. Okay, then we break up into those two cases. X minus 3 equals 1, and x minus 3 equals -1. We add 3, we will get x equals 4. Oh my goodness. You guys didn't tell me I graphed it wrong. It's okay. I'll change it in a second. And added 3. X equals 2. Okay? So those are our solutions. So obviously I did something wrong. Right? And if you wrote down your notes, I literally said vertex is at 3, -2, and I graphed it at -3, -2. So I make those mistakes as well. So I'm going to regraph it so that we make sure we get the right graph. Right? I promise I did not do that on purpose. I make mistakes as well. Only human. Okay? So the vertex would have been at 3, -2, up 1 over 1, up 1, back 1, making sure it's symmetrical on both sides. This would have been our V, okay? Which means that it would have crossed at these 2 points here, which are 4, 1, and 2, 1, which makes our solutions 4 and 2, which matches up here. Okay? Totally my mistake. Alright, now let's pretend that this right here is a greater than -1. Okay? So now we have our graph over here. We've already graphed this absolute value, right? We have it right here. Perfect. Got it. Check. Done. So what's the stuff that we have to deal with? Well, this right here. Right? That's what we got to deal with. Okay? So let's try and graph that line. Right here, this line. Y is greater than -1. Well, we already have the line y equals to -1. Now we just have to include the shading, right? Because when we graph inequalities, we shade an area. So y is greater than -1. Well, that's greater than is above. So that's all of this up here. So all of this up here is all solutions. So anything on this line, right, in this interval is what we call it. Those are all solutions because it's in part of the shaded region. So it's a red because it's shaded, and it's a purple because that's part of the purple line. So it has the double colors. It's true for both situations. So let's pick one of those and see if it actually worked. So right here, let's pick this point and see if it works. This point right here is 0, 1, 0, comma 1. So when x is 0, plug it in, see if it works. This should be a dashed line. Okay.